So let's take a look here and see how you did. The first one, 28.8 pounds per 1 square foot. How are we going to convert that? Well, we got to either convert the pounds or the square feet. Which one did you guys start with?
I did ounces.
Pounds to ounces? So you're going to put pounds on bottom, ounces on top. Why do the pounds go on bottom? So they cross cancel, yes. 1 pound is 16 ounces. So we have successfully changed it to ounces. Now we need to change the square feet into square inches. 1 square foot's how many square inches? 144. Now this time, of course, I put the square feet on top so they would cross cancel, because square feet were on bottom before. So now it is 28.8 times 16 times 1 divided by, on bottom, all that's there is 144. 28.8 times 16 and then divided by the 144. 3.2 ounces per square inch. Anybody get that?
Oh, I got that, but I did something in a confusion style doing it, but I got the answer though.
Okay. As long as it's something you can do every time and get it every time, that's all that matters. So now here, 42 milligrams per milliliter. So 42 milligrams per 1 milliliter. And we want to convert that into grams per liter. Now I'm going to show you a shortcut here that we haven't necessarily seen before. And what it is this. To get from, I'm just going to convert my milligrams into grams. Milligrams to grams on the chart is 3 spots to the left. So I move my decimal point 1, 2, I have to add a 0, 3 spots to the left. That's 0.042 grams. Now I'm going to do the same thing with milliliters to liters. That's also 3 spots to the left on the chart. So I'm going to take my decimal point here and go 1, 2, add a 0, 3, add another 0. 0.001 liters. But now, of course, I have to divide that out. 0.042 divided by 0.001 is 42. So that one just stays 42. How many of you had 42 for that one? 1? How many of you didn't get that one all done?
I ended up getting 42,000, but I think I forgot to put the decimal.
Okay. 3.7 square yard, cubic yards. I don't even need to write this one out. I'm going from just a single unit here, yards, cubic yards into cubic feet. Is the unit getting smaller or larger? Smaller. Yards to feet is a smaller unit. The number has to get bigger, so I'm going to multiply by, careful, cubic. So 3 times 3 times 3 is 27.
27 is what I said.
3.7 times 27. There you go. Nobody heard different, darn it. So 99.9 cubic feet. Anybody get that? 2 of you? Cool. And finally, 27 grams per 1 cubic centimeter. And we can do the same thing here. We can go grams to kilograms is 3 spots to the left. So my decimal point goes 1, 2, 3, add a 0. 0.027 kilograms. Cubic centimeters to cubic meters. Well, from centimeters to meters is 2 spots to the left on the chart, so the decimal has to go. It's 2 spots on the chart. The decimal point goes
To the left.
Yep. How far? 2 spots on the chart becomes 3, or 3 for each spot, so 6.
3 times 2 is 6.
Yep. So 1, 2, 3, 4, 5, 6. So that's 0.000001 meter cubed. If we divide that out, that becomes 27,000 kilograms per cubic meter. That's kind of heavy, just so you know. there are some metals out there that run about 27 grams per cubic centimeter. So that'd be about right. 27,000 kilograms or roughly 65,000 pounds in a cubic meter. Cubic meter is a lot of metal.
Not really.
Any questions?
For your little trick there,
Yep, this one.
yeah. Can you use that on all of them or just certain?
Just the metrics.
Just the metrics.
Just the metrics. Otherwise, what we could have done, of course, 42 milligrams per milliliter. We could have done, okay, this is going to go to grams, milligrams. 1 gram is 1,000 milligrams. This milliliters is going to liters. 1 liter. I did that backwards here. Milligrams should be on bottom, of course. Milligrams down here, grams up here. So 1 gram is 1,000 milligrams. So now what you'll see happens here is, milligrams cancel, milliliters cancel. 42 times 1 times 1,000 is 42,000 grams. 1 times 1,000 is 1,000 liters, and then the thousands divide out to give you 42 grams per liter. Well, there's good news and bad news. The good news is after today we are going to be done doing our measurement conversions. The bad news is that means that tomorrow is a test on measurement conversions.
Speaking of tests, did you get a quiz?
Yeah, it's sitting over here.
Okay.
I might get it back to you today. Okay, so what we're going to look at today, there's a couple of things. You guys deal, those of you that are in automotive and even in welding, you deal with electricity quite a bit. And I just want to review doing some of the operations with electricity. Now you guys deal with amps, volts, ohms, watts, joules, all the good stuff. And in electricity, you don't deal, and we mentioned this a little bit, we don't deal with them in most stuff. You don't deal with deca or deci or centi or hecto. It's amps, milliamps, kiloamps. You almost never deal with a kiloamp just because that's huge. But amps, milliamps, sometimes even micro. So you've got kilo, which is 10 to the positive 3. You've got milli, 10 to the negative 3. There's 1,000 milliamps in an amp. You've got micro, 10 to the negative 6. You don't usually get down to nanoamps or nano. You will occasionally get like mega ohms. A mega is 10 to the positive 6, or a million. Now the reason I'm listing them out like this right now instead of doing the chart is because I want to look at doing some calculations with the electrical units. We did this a little bit before when we did scientific notation. But let's say that we are dealing with Ohm's law. Ohm's law strictly states that the voltage is equal to the current times the resistance. You guys dealing with cars are dealing with DC, so that's why you can use just V for voltage. If you're dealing with AC current, like in the wall outlet, we would use E instead of V. It's for electromotive force, because it's technically not a pure voltage when you're dealing with AC current. But anyway, so we have our V equals IR. And let's say you're in a situation where your current is 28 milliamps and your resistance is 1.2 mega ohms. What's that? finding the voltage. So our voltage is going to be the 28 milliamps times the 1.2 mega ohms. Now, most of you probably what you did was you did this. You did 0.028 amps, change your milliamps into just amps, right? Is that what you've done in your DC electrical?
No, I don't think so.
Rick usually doesn't work with the metric prefixes. And change the 1.2 mega ohms into 1,200,000 ohms. And then you multiply them out. But we don't have to do that. We can simply do this. We can remember that milli is 10 to the negative 3, right? And mega is 10 to the 6th. And we can just multiply 28 times 1.2, which is 33.6. 10 to the negative 3 times 10 to the 6 is going to be what? 10 to the third, right?
Could
This
you,
is negative 3 plus 6 is 3.
would there be? No. No, never mind. Go
You sure?
ahead. Go ahead.
You sure?
Yeah,
Okay. So that means this is now, of course, this is volts because an amp times an ohm is a volt. This is 33.6. 10 to the third is kilovolts. Is our voltage. So you can work with those metric prefixes by using the powers of 10 and what we learned before with combining those powers. What if I have a power formula where power is equal to I squared times R? You guys seen that version? Power equals current times voltage. But voltage is equal to current times resistance. So that means power is current times resistance. So I squared times R. So if you have the current is 32 milliamps, and the resistance is 200 kilo ohms. Now again, you guys may have done just 0.032, changed the milliamps into just amps, and the kilo ohms into just ohms, but we're going to leave it that way. 32 milliamps squared times 200 kilo ohms. So 32 squared is 1,024. Milli, remember, is 10 to the negative 3. 10 to the negative 3 squared is 10 to the negative 6, right? Because when you take a power of a power, you multiply. So negative 3 times 2 is negative 6, which is a micro. Right? Then this will be 200 kilo ohms. So now I have 1,024 times 200. $204,800. And I have micro times kilo. Kilo is 10 to the third. Micro is 10 to the negative 6, correct? Well, negative 6 plus 3 is 10 to the negative third, right? Or milliwatt. So I have 204,800 milliwatts. Now, am I going to leave it as milliwatts? No, we don't like having more than 3 digits in front of our decimal point. So we're going to do this. We move it over 1,000 or 3 decimal places. That would take us from milli to just watts. So that's 204.8 watts. When you guys are dealing with like power in your house, by the way, if you ever look at your electric bill, it's like 14.2 cents per kilowatt hour. Oops, got my notation right. Kilowatt hour. You know what a kilowatt is? That's something that uses 1 kilowatt of power running for an hour. That's a kilowatt hour. So for example, let's say you have a light fixture, and most light fixtures have 2 bulbs in them. So let's say you've got a room that has 2 bulbs, 2 60-watt bulbs. And how long do you want to leave that light on every night?
4 hours.
4 hours a day. That's going to be 30 days a month we're going to go with. So it is on for 4 hours a day times 30 days a month. It's on for 120 hours every month. So 60 watts times 120 hours is 7,200. That is watt hours. Now, we said kilowatt hours. A kilowatt is how many watts? 1,000. So to get from watts to kilowatts, we've got to go 1,000 or 3 decimal places. 1, 2, 3. That is 7.2 kilowatt hours that light fixture uses in a month. So times 14.2 cents. $102 basically. 102.24 cents. So $1.02 is what it costs to leave that light fixture on for 4 hours a day for a month.
That's not too bad.
Let's say we're going to switch that out to your compact fluorescence. So it's still 2 bulbs, but now it's doing a 15 watt. Actually, some of them are down to like 7 or 8 watts for a 60 watt equivalent. If you do the math, it's now 15 watts times 120 hours, which is going to give us 1,800 watt hours, or 1.8 kilowatt hours. If we do 14.2 cents times 1.8 kilowatt hours, that's going to come out to be $25.56. So about 26 cents a month. So you're saving 76 cents a month just on that light fixture. So if you think about that, if you've got a couple of different lights that are on in the house that amount of time, you can save a few dollars a month just by having the compact fluorescence. Now, is that enough to pay for the fact that the compact fluorescence costs like 4 times as much? Yeah. All depends on how long they last. A compact fluorescence is supposed to last about as long as 3 or 4 regular incandescent bulbs as well.
Which usually is about a year.
I've seen one fluorescent bulb that has been on for 10 years and never been shut off. And it finally
kicked out.
Actually, I think it was still going. This was back when I was out in New Jersey.
Yep.
One of my neighbors left the fluorescent light on in the hallway all the time, and it was never shut off.
Yeah.
And when I went and visited there, it was still on.
Yep.
But I don't know if they changed it or not. But,
Sure. Huh.
but 10 years running, it never shut off.
Well, those old fluorescent tubes, the compact fluorescents are not quite as durable, but the fluorescent tubes, yeah, they would last forever.
Yeah.
The mercury vapor bulbs that they use in the street lights actually don't use mercury anymore, but they use sodium vapor. Those things will last for years. But it's a pain to get up there and change them if they go out, so they got to use something that's going to last. We also want to look a little bit at time. I mean, we've used this some, so I'm hoping you guys all know, of course, 1 minute is 60 seconds, 1 hour, 60 minutes and 1 day. This is how long it is between now and your test. No. It's 24 hours. But do you know what a millisecond is?
1 second, is it?
Thousandth of a second. And there's also microseconds. So this stands for millisecond. A microsecond would be abbreviated like this. That is a millionth of a second. Just like with your volts and amps and everything else. Finally, let's look at temperature. When we talk about temperature, there's usually two benchmarks we look at. We look at the point where water freezes and water boils. We have Fahrenheit and we have Celsius. In the Fahrenheit scale, what temperature does water freeze?
32 degrees Fahrenheit.
32 degrees Fahrenheit. What temperature does water boil?
About 25 degrees Fahrenheit.
212 degrees Fahrenheit. Where it boils. Where does water freeze in the Celsius scale? 0 degrees Celsius. And boils?
50 degrees Celsius.
100 degrees Celsius. The Celsius temperature scale used to be called the centigrade, or sometimes is still called the centigrade scale. Centi means 100, grade means gradients or divisions. So there's 100 divisions between water freezing and water boiling. That's what it was based on. On the Fahrenheit scale, they just started assigning numbers to the temperature, and it just ended up, they didn't plan it around water. It just ended up water freezes at 32 degrees. So you'll notice a couple of things. One is, in the Celsius scale between freezing and boiling, there's 100 degrees. And in the Fahrenheit scale, there's 180 degrees. Which means a Fahrenheit degree is much smaller than a Celsius degree. The other thing you'll notice, Celsius, water freezes at 0. Fahrenheit, water freezes at 32. What this means is we have something different from any of our other measurements. In all of our other measurements, there was a common 0 point. 0 feet equals 0 meters. 0 kilograms equals 0 pounds. 0 milliliters equals 0 gallons. So there's a common 0 point, so we could just use that conversion factor. Here, there's not a common 0 point, so we can't just use a conversion factor and change our temperatures. We have to use a formula. And the formula to go from Fahrenheit to Celsius, if we have Fahrenheit. Our temperature in degrees Celsius is going to be our Fahrenheit temperature. We will first subtract the 32 degrees and then multiply by 5/9. Where does the 5/9 come from? 100 over 180 reduces to 5/9. So let's say, let's do human body temperature, 98.6 degrees Fahrenheit. Let's see what that would be in degrees Celsius. So 98.6 minus 32. This is 5/9 times 66.6. 5/9 times 66.6 is 37 degrees Celsius.
Wait, where did you get the 5/9 from again?
That's the 100 degrees divided by 180, that reduces to 5/9. So let's say I have degrees Celsius and I want to go to degrees Fahrenheit. My Fahrenheit temperature is just going to be the reverse of this. 9/5 instead of 5/9 times my Celsius temperature. Then we add the 32 degrees. That's actually a very important process I just went through here. Here, the first thing that happens, I subtracted 32, then I multiplied by 5/9. To go backwards, I got to deal with the 5/9. So I'm multiplying by 9/5. and then I'm adding the 32 back on. I'm reversing the process, exactly reversing the process. So let's say the weatherman comes on and says it's going to be a 28 degrees Celsius day. Is that a nice day?
No.
Well, let's put it in. 9/5 times 28 degrees plus 32. 9/5 times 28 is 50.4. Plus 32 degrees is 82.4 degrees. I would take that any day of the year. That to me is my perfect, 70s into the low 80s is my perfect temperature. Actually, 70s is best for me. I might be better insulated than most.
Yeah, I like it in the 50s and 60s.
I'm not much of a 90s person.
I like the low 70s, high 60s. Woo!
So convert negative 40 degrees Fahrenheit into degrees Celsius in your notes. See what you come up with. So negative 40, you're going to subtract the 32 first, and then you have to multiply by 5/9. So negative 40 minus 32 is negative 72 times 5/9 is negative 40 degrees. Negative 40 is the one temperature that's the same on both scales. That's where the two scales overlap or meet.
I was gonna say I kept coming up with negative 40.
But unfortunately, doing the first part of the process and not finishing doesn't count. Because if you drain the oil out of the car, just don't put it back in, you're in trouble.
Yeah. Wait. Can I just interrupt your thought there? Can we go back to that? Okay, if I ended up with negative 72 and include that, can we go through that again?
The next part would have been then the negative 72 still has to be multiplied by the 5/9. This is now not in the packet anymore. This is back out of your textbook. Page 154, 1 through 31, the odds. And on page 156, 1 through 19, the odds. That's dealing with the temperatures.
Is this gonna be on a test file?
Yes, there will be a little bit on your test. And yes, tomorrow, for those of you that didn't catch it, tomorrow is our Unit 3 test. Or Unit 4 test, sorry.